Hello everyone, good afternoon. Myself Padmakant Dhage, Assistant Professor ENTC Department, Walchand College of Institute of Technology, Solapur. My topic is Continuous Time System, Part 3. At the end of the session, student will be able to explain properties of convolution integral to know the properties of continuous time LTI system. Properties of convolution, content, properties of convolution and properties of continuous time LTI system. First one, we will see the properties of convolution. Consider two signals x1 of t and x2 of t. The convolutions of two signals x1 of t and x2 of t is given by the equation x1 of t convolution to the x2 of t is equal to integrations minus infinity to the infinity x1 of tau to the x2 of t minus tau d tau. Herein, the asterisk symbol will always be used to denote the convolutions, not multiplication. There are three mathematical properties of convolution. First one, commutative law. Next one, distributive law. And last one, associative law. Other properties of convolutions are shifting properties, convolutions with an impulse, and last one, width. Mathematical properties of convolutions. First one, commutative law. x1 of t convolution to the x2 of t is equal to x2 of t to the convolutions of x1 of t. If x1 of t is given input to the x2 of t, then final output we will get y of t. Then x2 of t is also given to the input to the first one x1 of t, we will get output y of t, same output. Hence, the order in which two signals are convolved makes no difference. The results are identical. Next one, distributive law. x1 of t convolution to the bracket x2 of t plus x3 of t equal to x1 of t convolution to the x2 of t plus x1 of t convolution to the x3 of t. If x1 of t is given to the simultaneously x2 of t and x3 of t, which is also given directly to the its output to the summations, we will get final output y of t. Then, in other words, x1 of t is given input to the blocks of x2 of t plus x3 of t, which is already added, we will get final output y of t. Here, the distributive property shows that parallel systems with added outputs can be replaced with a single system. Third one, associative law. x1 of t convolution to the x2 of t convolution to the x3 of t equal to bracket of x1 of t convolution to the x2 of t bracket complete convolution to the x3 of t. If x1 of t convolution to the x2 of t is given as an input to the x3 of t, then we will get final output y of t. Or x3 of t given input to the blocks of x1 of t convolution to the x2 of t, we will get same output as a y of t. That is, the associative property states that the order of the convolutions doesn't matter. Other properties of convolutions. First one, shift property. If x1 of t convolution to the x2 of t, will get z of t. Then x1 of t convolution to the x2 of t minus capital T bracket complete equal to z of t minus capital T. Proof. x1 of t convolution to the x2 of t minus capital T equal to integrations minus infinity to the infinity x1 of tau into x2 of t minus capital T minus tau d tau, that is equal to z bracket of t minus capital T. Similarly, x1 of t minus t convolution to the x2 of t is equal to z of t minus capital T, and x1 of t minus t1 convolution to the x2 of t minus capital T2 is equal to z of t minus capital T1 minus T2. Convolutions with an impulse. Convolutions of signals x of t with a unit impulse is the signal x of t itself, that is, x1 of t convolution to the delta of t equal to x of t. Proof. x1 of t convolution to the delta of t equal to integrations minus infinity to the infinity x of tau delta t minus tau d tau that is equal to x of t. Here we have used properties of delta of t minus t1 equal to 1 for t of all values of tau, or 0 equal to for otherwise. Last property, width property. Durations of x1 of t and x2 of t are t1 and t2 respectively. Then the durations of the signals obtained by convolutions x1 of t and x2 of t is t1 plus t2. Properties of continuous LTI system. The impulse response plays major role in analysis of LTI systems, focusing to reduce the conditions for impulse response of LTI system with respect to different properties of LTI system. First one, memoryless and dynamicity, continuous time LTI system. Next one, invertibility and inverse continuous time LTI system. Third one, causality. Fourth one, stability. Fifth one, unit step response continuous time LTI system. First one, we will see memoryless or static continuous time LTI system. The continuous LTI system whose present output is dependent only on present input value is referred as static or memoryless system. That is in equations format, y of t equal to x of t convolution to the h of t equal to integrations minus infinity to the infinity x of tau h of t minus tau d tau. That is given by equation number 1. H of tau equal to 0 for t is not equal to 0. That is given by equation 2. Next one, property. Memoryless or dynamic continuous time LTI system. The continuous LTI system whose present output is not dependent only on present input value is referred to as a dynamic or memory continuous time system. If above conditions equation 2 is not satisfied the LTI system, then LTI system is dynamic or with memory. Invertibility and inverse continuous time LTI system. A continuous LTI system is said to be invertible if there is a one-to-one mapping between input and output. For given system, if we construct inverse system which cascaded to the original system produces the output equal to original input, then the given system is said to be invertible and the constructed system is referred as an inverse system. If following equations 1 satisfied, then h of t is invertible system with h1 of t its inverse system. H of t convolution to the h1 of t equal to delta of t, which is given by the equation 1. Here x of t given input to the h of t which produces the output y of t, again it is given to the input to the h1 of t, then produces final output z of t. In other words, x of t is given input to the h of t, which is h of t convolution to the h1 of t is equal to delta of t, which finally produces the output y of t. Third one, causality continuous time LTI system. A continuous LTI system is said to be causal or non-anticipatory if its present output depends on only present and maybe past values of input, that is h of tau equal to 0 for t tau less than 0, y of t equal to integrations minus infinity to the t x of tau h of t minus tau d tau, which is given equation number 1. Equation 1 modified, y of t equal to integration 0 to t h of tau x of t minus tau d tau. Fourth one, stability of continuous LTI system. A continuous LTI system is said to be stable if for bounded input signal system produces bounded output signal, its impulse response h of tau should satisfy following conditions, which is given by integrations minus infinity to the infinity mod of h of tau d tau less than infinity, which is given by equation 1. That is, the impulse response should be absolutely integrable. Fifth one, unit step continuous time LTI system. Let h of t be the impulse response of continuous LTI system. Let u of t be the input to the same LTI system, corresponding output to be the denoted as a s of t. Here delta of t is given input to the LTI system which produces the output h of t. In other words, u of t act as a delta of t which is given input to the LTI systems and produces the output s of t. We know that unit step is related to the unit impulse delta of t by following relations: unit of u of t equal to integrations minus infinity to the infinity delta of tau d tau. That is, continuous time unit step is running integral of the unit impulse, therefore naturally s of t will be running integral of h of t. Here delta of t, that is unit impulse, same act as a u of t as input, produces the output s of t for the unit step signal, same as a h of t for the delta unit impulse signal. S of t equal to integrations of minus infinity to the t h of tau d tau, which is given by equation 1. H of t equal to derivative of s of t to the dt, which is given by equations 2. Since impulse response can be easily computed by simply differentiating the step response. Here references are used: Signal and System, Ramesh Babu and Anand Natarajan, 3rd edition, Scientific Publications, Signal and Systems, A.V. Openhain and A.S. Wilsky, Pearson Educations. Last one, Signal and System, Dr. D.D. Saha and A.C. Bagli, Mahalakshmi Publications. Thank you.